Hi, and thanks so much for coming to visit my booth. My name's Emily, and I'm a master's candidate from Dalhousie University, and I'm studying the use of remote sensing for mapping habitat change. So for my booth, I'm going to do a quick overview of a story map that I created through ArcGIS that kind of details the general idea of my project so far and how the methods for my project work, especially because I am kind of in the first years of my master's so far. So this entire project that I'm going through right now, if you click on the link on Hopin, you can actually go through all of this yourself with a bit of extra detail included, and you can also go through the maps yourself to look at Bimini and the habitat that I'll be mapping. So I've called this project Sharks from Space because I'm working with shark species, but also trying to use space technology like satellites to map habitat changes in Bimini. So a bit of background on Bimini. Bimini is located about 85 kilometers east of Miami, adjacent to the Gulf Stream. So you can see the very, very deep water just west of Bimini. And so that kind of makes Bimini a refuge for a lot of shark species. One of the shark species that Bimini is important for are lemon sharks. And the island's characterized by mangrove-dominated islands surrounded by seagrass beds, sand flats, and an interior seagrass lagoon. So all of this makes this area very important for juvenile lemon sharks that have nursery areas around the island that they're philopatric to. And the juvenile lemon sharks will actually reside in their own specific nursery area and return to that nursery area if they're moved as well. So those nursery areas are North Sound, Sharkland, and South Bimini, which you can see on the map. Unfortunately, in the past few decades, habitat destruction has occurred with new developments on the island. Most notably, and you can kind of see the change happening here. So this is where a lot of the construction has happened. So there was dredging in 2001 for a boating channel on the west side of the island. There was removal of mangroves and some infilling in this red portion of the island. And then most recently in 2019, 2020, I don't have the exact area, but in this area generally, there was some development of new roadways. So the difficulty with these developments is that it's hard to quantify this change in habitat over such a long time period because there have been some smaller changes throughout this time as well. And because of this, it makes it difficult to further understand the implications of this habitat change on the lemon sharks. But satellite imagery collected by NASA can fill these important data gaps because it has been collected for so many decades. So my study goals are to first map the nursery habitats over 2 decades using the satellite imagery, then to assess the annual shark capture and fin clip stable isotope data, and then finally combine these two to understand the long-term impacts of habitat degradation on lemon shark abundance, survival, and diet. So my two main research questions revolve around these study goals, with my first one being what are the long-term changes in seagrass and mangrove distribution, and the second one focusing on how the juvenile lemon shark abundance, survival, and diet has changed with the long-term habitat change. So for my first question, I'm going to be using mostly remote sensing, and this uses satellite imagery collected by NASA, which has been collected since 1984. And so because of this really long time span, we can assess the habitat change throughout these 2 decades. Now, these satellites collect imagery, which is classified into bandwidths, which can then be classified into habitat using in situ data. So each pixel of an image reflects a certain amount of each bandwidth, so a certain amount of red light, green light, and blue light, as well as near infrared. So as an example, I've included these charts showing the amount of red, green, blue, and near-infrared bandwidths reflected by mangrove habitats, where you can see there's a lot of near-infrared light reflected by these habitats. And then what's reflected by seagrass habitats, where you have quite a bit more green light that's reflected, but also a lot more blue because it is found underwater. And so by looking at all of these, you can classify pretty clearly different benthic habitats. So this is a study done by Kristen Wilson off the coast of Nova Scotia. And here on the left, you have the unclassified image with just the raw satellite image with the land removed, which is the gray that you're seeing. And then on the right, you can see how that image has been classified into non-vegetated and vegetated habitats. with the green representing the vegetated habitats of varying densities. So what we can further do with this is with algorithms such as the automated adaptive signature generalization algorithm, which is a bit of a mouthful, you can map the habitat across multiple decades with just 1 year where in situ habitat data has been collected. So you can use that to predict what the past years have had for habitat with their own imagery, which is really useful for a study like this where we're looking at such a long time span. So my goal with this part of my project is to make the benthic and coastal habitat maps of Bimini for each year from 1999 to 2021, and then to calculate the actual total hectares of seagrass and mangrove coverage for each year and the difference or change between years. And so for my second question, I'll be using surveys and isotope data from these juvenile lemon sharks. So the Bimini Biological Field Station Foundation has collected these surveys or done these surveys for the past several decades. So on the right, I have a map of where these surveys were completed, and each of these points refers to one survey location that has been looked at each year. And so you can see there's a good coverage of both of the Sharkland and North Sound nurseries, if you remember where those were from previously. So these surveys have tag recapture sampling, as well as stable isotope sampling from fin clips. And it's estimated that 80% of age 0 juveniles are recaptured the following year at age 1, which is shown in this plot here by Christine Stump from her previous work looking at survival rate of the lemon sharks. So by looking at this recapture of each lemon shark, you can estimate the survival per year, and then I'm hoping to compare that to the hectares of mangrove and seagrass coverage and see if there were some long-term impacts and potentially delay in the impacts of this removal of habitat for these juvenile lemon sharks. So finally, I'll also look at the fin clip stable isotope values, specifically for carbon. So on the right, we have a previous study by Nigel Hussey et al., who looked at the stable isotope values from prey species in the mangrove habitats, which you can see in the red dots on the left. So they had lower carbon stable isotope values. And then compared to the seagrass prey species, which were found to have higher stable isotope values. And in the middle with the blue dots there, you see the carbon stable isotope values for the lemon sharks. So what I'm hoping to see is a shift in habitat use and foraging habitat specifically for these juvenile lemon sharks with the change in their habitat as well. So my main goal for the second question is just to create a model showing how the changes in habitat have affected survivorship as well as the foraging habitat of these juvenile lemon sharks and be able to quantify that specifically as well. So the significance of this project so far is that we'll be able to create baseline maps of habitat coverage so that future mapping can be completed and monitoring of this habitat change to make sure that everybody makes sure that we know what habitat is being destroyed or how to protect different areas of habitat as well. It's also going to help quantify that long-term impact of the habitat disturbance on the juvenile lemon sharks. And then hopefully this helps to vouch for the importance of these coastal habitats for juvenile lemon shark nurseries and improve conservation of these areas. So I'd just like to acknowledge everyone that's helped me so far with this project, including my supervisor, Heike Lutz, and my committee members. And this project's made possible by Dalhousie University, which resides on the territory of the Mi'kmaq people. And I really encourage you to visit nativeland.ca to learn about what territories you reside on, which I've also included a link to in the story map in this hop-in platform. So I encourage you to take a look at that story map, play around with the maps yourself, and if you have any questions, I'd be happy to answer. Also, I hope to see you in Valencia because I'll be presenting a poster there as well. So thank you.